video is just going to be um, a walkthrough of the code that I use to find um, the snake cube that's the snake square that works together. And just as a warning, I am a total amateur in coding in general and in R, which is basically the only thing I used. I took a stat class that used R, and I kind of just have used it here and there. Um, and so, but the internet community that uses R is awesome, and I was able to figure out pretty much everything that I needed. And so I'm just going to walk through what I did, and I'm sure many of you will have comments of how I could do it better or differently or whatever, and that's awesome. This is just what I did. So of course I start by putting in the starters, the cube. So like the three columns that you saw in the last one, and then these are the setup. So it gives me the square position of all the cubelets and the neighbors for all of them. Seed 1 is just the first line. So the 1, 2, 3, as you can see down here. And run 0, just because I have it stop every 5,000 paths that it finds and run write it to a CSV. So that just helps me keep things organized. So the first thing is starts the path, so it sets up the path from the seed that I give it. In this case, the 1, 2, 3. You can see it up here. Path. And then options. So options comes from the neighbors of the last one. So in this case, the neighbors would be these two, and then there'd be a 0 here, and of course this would still be a neighbor. But that first step here sets the difference, so it takes off the path and just has ones that are not part of the path, and then also takes off any zeros that might be. So for example, there'd be a 0 down here as that option. So it would take that off, and it makes it a vector, and then it plugs that into the third place on the option list. The first two are hard-coded with just kind of restricted options, and then the third one has real options. Okay, for the snakes, so this so paths run based on the cube. So I have 1 through 8, and then 9 through 16, and on up till 64. Those are just the kind of names of the cubelets, or the squares in this case. But then the snake, so the path says 1, 2, 3 in this case, and then if it went up here, it'd be, what is that, 11, and it goes on that way. But the snake will say 3 for this end, and then a 1 because that's straight through, and then if it turned up here, then this would be a 2. If it went straight to this spot, this one would be a 1 as well. So it's a string of 1s and 2s with 3s on the end. So this here gives it the end. 3 kind of looks like E for end. 2 is curvy, so it's the turn piece, and then 1 is straight, so it's the straight piece. So what this bit of code does here is just says if these things work out, this basically is a way to show whether it's straight or not. And if these are straight, then you give it a 1 straight, and if not, you give it a 2. Okay, that's just, I changed it to make the last video. And then paths and snakes, plural, those just take all the full paths and full snakes of link 64. And then this tester starts out at 0. 0 is false, which means, for whatever reason I did it that way, just means you're going to proceed. If it becomes true, then it's going to be a step back. So that's the kind of walking mechanism. If it has an option, it takes it and goes forward and makes the path longer. If it doesn't have the right options, then it steps back. Okay, after doing some other things that left gaps, and you can kind of, if you look at the other video, you can kind of see the things that I was talking about. There would be some times where it would eventually get to the right answer and wouldn't give me any false things, but it would would take a long time to get where it needed to be. So I had to come up with a way for the algorithm to figure out ahead of time that the path that it was pursuing was fruitless. So I came up with the ANSI path, and then this component, basically the component starts, it just starts from one of the pieces of the antipath and grows until it's blocked. All this is not something I put in the actual code, but I stuck it in there to make the PDF for the video last time. Okay, so you can just see that that's what we have over here already. Okay, so then this piece, what it does is what I just said. It's making sure that to see it's giving a component, and in this case, all the things are the same, right? All they're connected. So that's what this checks. It says if there are more in the ANSI path, which would be all the blue things, than there are in one connected component, then you need to turn the tester true, which means backtrack. And then also, the next thing is looking for, so let me show you here. Basically, it looks through all the options. So of all these, so you can see down here, all of these are the names of the blocks that are part of the ANSI path, and this is how many options they have. And so if any of them get down to one option, that's okay. That would mean you can go into it, but you can't go out of it. So if there are, that's what this up here is saying. If there are two or more that just have one option, then two places have no exit, so that's not going to work. So tester goes to 1. So that's for backtracking. Also, if the place on the option list, so the last spot here, that's the length of the path. If that option list, the length of that option list is 0, that means it has no options. Then of course you're going to put the tester to 1. It means get ready to backtrack. Okay, so now if the tester is 1, it does the clear thing. It backtracks. That means it takes off the last piece of the path and takes off the last piece of the snake. But before that, it looks at the penultimate, the second to last option list, spot in the option list, the list of options for the previous one. So in this case, it would be this one. And it says if this has to backtrack, then we want to take this option out of here. So from 2, it wouldn't be able to go to 3 again. So that's what this does. It says if you have to backtrack, you take that off, and then take off the last snake and the last kubelet of the snake and the last kubelet of the path. Okay. But if just do all that. Sorry. All right, if the tester is 0, that means we want to move ahead. So you take the first option from the options given here and add that to the path. And then we want to work with the snake and say, okay, well, after you've done that, after you've gotten the new path, then you're going to look at those last 3 pieces, and if they're in a straight line, then you're going to call that a 1, and otherwise you're going to call it a 2. And then it also says, okay, well, if you happen to have reached the 64th spot in your path, then you need to write that to full paths, or paths here, which is like a full path, and then also put the ending on the snake, and then write that to snakes, and then you take off the ending again, just so it's ready to move on to the next exploration. All right, and then we go through the process of doing the options again. It does the options, and we go through there. Okay. So what this is doing is saying, because I want it to also fit a cube, I know that I can't have more than 2 straights in a row. So that's what this does. It says if you've already got, if the last one is a 1, which is straight, and the one before that is a 1, which is straight, then take off the option that would make another straight. And then also take off the option, any options that are in the path, take off the zeros, and then write your new space in the option list. So you tack on a new place in the option list. And then this one says, if you've gotten back to 1 less than the seed, so if I got all the way back to 2, then I should break, because I've exhausted all my options. So I break. And the other one, that's this. I changed it for the get ready for the video, the other video. But if it goes to 5,000, then it breaks and writes it, and that's what that's basically what I want to do, right? Because I want it to be usable, and for my machine, 5,000 on a CSV is good for me. So it takes those 5,000, and then we can do a new run after that. That's the run goes up. Okay. All right, and then this is just the saving part, right? So my paths was just a long string of numbers. This is just breaking it into its groups of 64, and then writing the CSV, and then same thing for the snakes. All right, and then you can see we've got that again. And then, of course, we can do the points too. But anyway, yeah, I know. Because of the position of where it is, and it hasn't re-evaluated the answer path yet. So this is kind of out of sequence right now. Okay, and so that's basically it. It just keeps doing that over and over until you could just run it through all of those until that seed is exhausted, and then move on to the next seed until all the seeds are exhausted. And that would get you all of them, I believe. And again, like I talked about, there would be a few that are the reverse of ones that are given. So if I start with 1 and end up over here at 10, then maybe I'd start at 10, and I would certainly find one that would get me back to 1, and those would be counted as unique, even though really they're the same. So I don't have that option either. I didn't deal with that. Clearly some snakes are going to be reused, and I deal with that. Okay, so now I'm going to go ahead and talk about moving from, okay, so I found tons and tons of paths, thousands upon thousands of paths, and now I want, and made snakes along the way as well. And so now I want to figure out what whether any of those snakes will make a cube as well, a 4x4x4 cube. And so that's what this part does. Basically reduces the snakes, finds out what unique snakes there are. I read this starter in. I had a bunch of starters, and so that's what this does. Essentially, it's the same mechanism, but the way that it finds its options is based on the position in the snake. So if the snake is a 2 in the 3rd position, then it only gives that position 3rd, and it goes through and checks each sequence, and if it fails, then it backtracks. If it finds a fit, then it moves on to the next cubelet and takes those options based on whether it's a straight or a curve, and it keeps doing that. And this is how, well, so there's that part. And then this is how it runs through. And basically, it starts it in, say, the corner of the cube, and tries to work it through all of the possible options from there, and then it moves to the second spot over and works through there and does kind of all of the unique starting points for one snake, and then basically says, okay, that snake, if it doesn't find anything, then says that snake is done. I've looked at all possible arrangements of that snake as a cube, and then none of them fit, so now I move on to the next cube and start over that process. And so that's essentially what that's doing. So here you can see the options. If it's a straight, which that's what this has all been saying, is telling me whether something's straight or not. If it's straight, then you only have one option. If it's a 2, you might have up to 4 options. If it's in the middle, you can turn 4 different ways, and so it might have up to 4 options. And so that's what that's doing, is creating the cube options, C options, based off of that. And then it just goes through that process until it finds one that works. And eventually it did find one that worked. And so that's pretty much it. And again, if it needs to backtrack after it, backtrack all the way to the beginning, then it breaks. If it somehow finds 5,000 paths that work, then it writes it again, similarly to the way it did before. And it keeps doing that all through all the snakes, and then I would just have to give it another one. So, for example, it uses all the snakes from a particular, so in this case, I'm using 140. So that's this snake sequence. So it'd be 5,000 of these. And then if I wanted to try another one, I'd just put in another ending here. And I could, I could put that into a cycle too, but that's, I didn't need to. And plus, I have to use my machine for other things, so I just didn't do that. It's kind of a do it as I can kind of thing. But for those of you who have, a machine that you can dedicate to it and kind of do it in the background or whatever as it goes, that's great. My little laptop can't manage all of that. And so hopefully you all have something interesting to tell me about the code and maybe not be too harsh. And thanks, and I hope this was cool for you, because I had this idea, and eventually I was able to make it happen, and I haven't seen anyone else make the snake cube square, and especially with the extra piece of fitting the chess pieces in. So hopefully you'll give it a look, and thanks for watching.